degree in fisheries at the University. Oh, thanks, Kristen. At the University of Wisconsin Stevens Point, a master's at the University of Alberta, and a PhD at the University of Calgary. His master's research used whole system experimentation to evaluate fish habitat offsetting projects at a diamond mine in the Canadian Arctic. For his PhD, he developed hierarchical modeling and stock assessment techniques for inland recreational fisheries in Alberta. Chris completed a postdoc at Simon Fraser University before transitioning to his current role as Associate Director of the Quantitative Fisheries Center at Michigan State University in August of 2022. Much of his current work and research in the Great Lakes focuses on the dynamics of exploited fish stocks in the Great Lakes. Chris will take questions as we go. For folks online, please feel free to use the Q&A box to type your questions in. And yeah, thanks everyone for coming, and a big thank you to Chris for sharing your work with us today. I'm gonna turn it over to you.
All right, well, thanks for the introduction, Leachy. Just so everybody knows, this talk probably wouldn't have happened if Leachy hadn't have cajoled me many times, just because I'm apparently terrible at answering emails. So thank you, Leachy. If you like the talk, thank Leachy. If you don't like the talk, it's my fault. With that said, yeah, so I'm gonna shut off I can't really see the camera or anything. So Kristen or Leachy, if I'm not answering somebody's question, just yell at me. But so I've been in this role for about a year and a half, a little over a year and a half, and it's been a pretty interesting experience so far. And I was excited to give this talk for a couple of. I was excited because it's UW, that's fun. And then the other thing is I don't think there's too many Great Lakes talks that folks probably get to see. So I was excited for both of those reasons. Let me see if my slide is actually, there we go. All right, let me get my little timer going so I can make sure I'm not hours over. So I spent a lot of time over the last 11, 12 years in Western Canada. I've lived in Alberta, worked in the Canadian Arctic. I lived in Vancouver for a little bit. And when I came to the Great Lakes, I thought I knew the Great Lakes were pretty cool. And then I came here and then I learned all this really other interesting stuff. And so the first part of this talk is kind of like a highlight reel of some just fun Great Lakes facts and cool pictures. And then because this is University of Washington, I figured I'd talk about some of the important fisheries that we have in the Great Lakes and some of the management concerns, some of which I've worked on, many of which I haven't. And then I'll give a brief history of like stock assessment modeling efforts in the basin kind of to date, right? So that'll be the first part of the talk. It's gonna basically be like a highlight reel just to familiarize folks with the Great Lakes and to kind of set the stage for the second part. And the second part is really what I've been doing for the last year. So and I'm going to talk about it in detail. It was cool to have a land acknowledgement there at the beginning, Leachy. A lot of the work that I've been doing has been with what are called the treaty waters in Michigan. And so I'm going to talk about that in excruciating detail. But a big part of what we've been trying to do is translate statistical catch age models that were originally coded in RTMB to RTMB for the 1836 and 1842 treaty waters. So the second part of the talk, I'm actually going to go into like the history of the treaty waters, what that means in the Great Lakes, the models that we've been playing with, and what we've been doing with RTMB. And then hopefully I'll have enough time at the end to kind of discuss, where we want this or hope this work will go in the future, what our strategic vision for this work moving forward is. So that's sort of the outline. Like I said, if you have any questions along the way, just chime in and we'll try and take it that way or whatever. We'll talk at the end too. Okay, so I guess something that kind of blew my mind was just let's just say there were a number of things about the Great Lakes that blew my mind when I started working here. And so this first section is just some fun facts about the Great Lakes. So this is one of my favorite pictures of the Great Lakes taken by the European Space Agency. And I guess the first thing to note is that this is a satellite and you still can't get the things in frame. Okay, so they're pretty big. I always try to say Laurentian Great Lakes to distinguish from the Canadian Great Lakes, like Great Bear, Great Slave, or the African Rift Lakes. I've got friends who work in both of those, but if I say Great Lakes for the rest of it, these are the five I'm talking about: Superior, Michigan, Huron, Erie, and Lake Ontario over on the far right. The second thing I really love about this picture for introducing the Great Lakes is that the first thing that catches my eye is just the bloom that's going off in Lake Erie. And it's pretty fascinating. It's not a harmful algal bloom, or at least it's the wrong time of year for there to be a harmful algal bloom. And I've asked a bunch of fish biologists and nobody actually really knew what that was. I should probably ask some hydrologists or other ecologists maybe. But the point is, there's just massive biogeochemical processes at play, kind of that you can just see from satellite images, which I think is just really neat. Another thing for the size of the Great Lakes, another thing that's really interesting here. I don't know if you can see my mouse, but you can.
Yeah.
Okay, cool. So anybody heard of the Coriolis effect, right? So the spinning of the Earth kind of affects the currents in the Great Lakes because they're big enough. And so actually what you get in Lake Michigan is currents that jut down the western side of Lake Michigan, rip around and pick up sediment and launch it out into the lake. So that's what you're seeing. You're seeing kind of like the physical manifestation of the Coriolis effect. And, you know, I know like some folks have probably flown over the Great Lakes, or maybe some folks are from the region, but if you're from Washington, to try and put this into perspective for how big from a surface area perspective this is, if you took these 5 lakes and just put them together, mashed them together, they'd, you know, the state of Washington would represent about 85% of that area. So the next time you're driving from Bellingham out to Spokane, or heaven forbid down to Walla Walla for 5.5 hours or something, you know, that's how much water we're talking about in the Laurentian Great Lakes. And I think that's, you know, something that folks often will gloss over, but they're just really cool systems. As soon as I moved here, somebody told me that they had tsunamis in the Great Lakes, and this just completely broke my brain. I didn't understand this. So apparently there's been some recent research, relatively recent research, on these things called meteo tsunamis, which are a unique weather event that happens apparently only in the Great Lakes right now, or the Laurentian Great Lakes. And so what happens is there's like these huge thunderstorms build up over the prairies, right? For however many miles, and they build up to these huge thunderheads, and then they get over the Great Lakes, and these low pressure systems, the pressure alone will create like tsunamis. And so in Ludington, which is the place that I work on fisheries, they actually had this crazy wave that just surged out of nowhere one day and flooded half the town and a whole bunch of stuff, and NOAA published articles on it and stuff. Anyway, just again, the lakes are big. To drive that point home, you know, they're big enough that they create their own weather. So there's things like lake effect snow that folks talk about a lot of the time and things like that. But if anybody's heard of the polar vortex that came through North America in 2022, I mean, there's been several, but the one in 2022 was kind of fascinating because it actually came down. You saw it tracking from Canada and across the Midwest, and it actually sat over the Great Lakes for like longer than it should have. The lakes just kind of like kept this whirling vortex of polar misery just centered on the Great Lakes for a good chunk of time. They're huge systems, and I just can't convey that enough. And, you know, I had seen pictures of the Great Lakes, and I just want to say there's a huge disconnect between lakes on a map and seeing them in person. This is a vessel finder search for the Great Lakes from this morning, right? So there's a ton of industrial shipping around the Great Lakes, and that's what these little yellow triangles are. But when that polar vortex was going through, I actually was driving from here. I'm here in Lansing. And I was driving up through here. There's a huge bridge that connects the upper the upper peninsula of Michigan to the lower part of Michigan. I was driving across this bridge, and there were sustained 40-knot winds that were kind of ripping through here. And there were like 16 to 17 foot sustained waves. I know that because I checked the buoys afterwards, and they closed the bridge. My point is, like, having worked all over the Arctic, being out on the West Coast, I'm not saying those things aren't cool, but man, the Great Lakes are a sight to behold, especially when there's a storm raging through. So if you ever get the chance to visit, definitely try to get out and check out some of this stuff, because it's pretty cool stuff. Okay, those are my 5 slides or so about cool facts of the Great Lakes. And now I'm gonna sort of transition to some of the fisheries of the Great Lakes. Again, recognize I've only been here for about 1.5 years, and I haven't really worked in the Great Lakes beforehand. So, you know, my training was all in Western Canada or in the Pacific Northwest, took classes at UW with lychee. You know, I'm kind of seeing this from somebody who hasn't been trained inside the Great Lakes. And so I'm just sort of trying to convey that, the complexity of these systems to you, I guess, if that makes sense. So I work for a group called the Quantitative Fisheries Center, the QFC, and this is what we work on. So the Great Lakes fisheries. So the Great Lakes commercial, recreational, and tribal fisheries are collectively valued at more than $7 billion annually and support more than like 75,000 jobs in the Great Lakes Basin. If you want to see how those numbers are generated, you can go down here and click on this link by the Great Lakes. It'll take you to the Great Lakes Fishery Commission website, which is a binational organization that sort of orchestrates fisheries research, management of invasive species all throughout the basin, right? So this is the number, 7 billion, that they use when they go to the Canadian or US governments to try and get funding to support Great Lakes fisheries research or management. A very small percentage of this is commercial. Most of it's recreational, frankly, or like charter boat fishing kind of things. And that doesn't mean that commercial fisheries aren't important. It just means that a small amount of the economic value is actually from commercial fisheries. So for the commercial fisheries, it's really lake whitefish, walleye, yellow perch, ciscoes, the boggle-eyed critter I had on the previous slide or a couple slides ago. They form the foundation of the commercial fishery. And then there's things like introduced salmon, walleye, rainbow trout, different kinds of trout, and muskies kind of comprise this world-class recreational fishery. And anglers flock here from all over the world to chase fish in these systems. They spend a lot of money when they do it. One of the things that's really interesting about the Great Lakes is that the fisheries are managed by tribal, provincial, and state government with help from the federal governments, rather than it being the other way around. And so that sort of means if you were on the West Coast, if you're in Vancouver, you think about DFO and the precautionary approach to fisheries management, right? Based on NOAA's Magnuson-Stevens Act and all of the legislation that's outlined in those fisheries. None of that really applies in the Great Lakes because it's managed by the states, the tribes, and the provinces, okay? And so that's really fascinating when you think about it from a jurisdiction or just a policy perspective. I think that's a really interesting aspect of what all the other stuff I'm about to show you kind of stems directly from that, or at least in part due to that. So at the QFC, what do? We work with as many of these groups as possible to try and affect meaningful, change in quantitative fishery stock assessment around the basin. That's really what we do a good deal of. So our role in the basin, this is just the front page of our website, but we try to build first and foremost, we try to build greater capacity within fisheries management agencies using quantitative methods, improving quantitative methods for assessing fish stocks, assisting agencies, and try to develop a better understanding of fish community and population dynamics as we go. But a big part of it is building capacity within agencies to actually conduct stock assessments or things like that. And so something to think about, like if you're at the University of Washington or if you're out in the Pacific Northwest and you're a stock assessment scientist, your whole job is probably programming and fitting this assessment model or whatever, right? In the Great Lakes, that's not really the case. So assessment biologists might be tasked. If you work with the state, you might have to do field work for half the year. You might have to do many other things in addition to running stock assessments. And that's just the way it is here. I don't know why, but that's sort of what folks do here. So we try to help these folks build stock assessment models and do the things that they need to do as per their agencies or groups' objectives. There's a lot of things in the Great Lakes that are worth mentioning, but one of the really big things that you'll hear folks talk about all the time are invasive species management. So the Great Lakes Fishery Commission was actually founded in part or largely to try and eradicate or reduce the effects of sea lamprey on Great Lakes fisheries. And so lamprey invaded through the Welland Canal, tanked fish populations all over the Great Lakes. This is one of these ugly little vampire things here. And so there's this whole they spray a chemical called TFM in streams where they think that there are these lamprey amicetes, right? They're trying to, this whole basin-wide effort, right? The U.S. Fish and Wildlife Service, agencies all over try to treat streams for sea lamprey. This is what they do to a lake trout fillet, and they get reduced prices for those fillets if they actually have holes in them like that. And so, I haven't worked a ton with the sea lamprey stuff yet. We've got some projects coming down the line, but that's a huge thing that a lot of our partners and folks in the Great Lakes are really concerned about. Another big thing, big-headed carp, right? So there's big-headed carp in the Illinois River and things like that. And so there's a lot of efforts that go into invasive species management as well. So that's a huge concern for most of the partner agencies that we work with throughout the basin. This one really blew my mind. I knew about it before I came to the Great Lakes, but then it really hit me when I came here. So the invasion of dracidid mussels. So zebra mussels invaded the Great Lakes in the late 80s, early 90s, and they were able to colonize sort of, I can't remember the exact depths, but they were able to colonize down to a certain depth around the Great Lakes, and they certainly had effects. Then quagga mussels got into the Great Lakes, and they've been able to go far deeper, and they've really altered the systems in remarkably impactful ways. So I show this figure, which is from Lake Huron, And if you read the old dive logs from divers in Lake Huron, they used to be able to see, for example, like 7 feet on a good day. Now you can see 40 to 50 feet. Like that's the magnitude of the water clarity changes that we're talking about in some of these systems. And at least in Lake Michigan, I think NOAA or somebody's got there's like fact tidbits. I don't know. I haven't checked the validity of them, but it seems reasonable. So there's so many mussels in Lake Michigan that every gallon of water in Lake Michigan goes through a mussel within about a week's time, or at least they've filtered that much volume of water. And so in the Great Lakes, especially in Lakes Michigan and Huron, we've seen huge declines in diparia communities, so like zooplankton communities, and there've been a lot of these productivity shifts and these like diparia declines and things have been implicated in a lot of fisheries declines in lakes around Michigan. It's just the water's clearer than it's probably ever been, right? And so, as an aside, if you're interested in non-stationarity or testing things like dynamic B0, it's probably not a bad place to think about it. But anyway, this Dracidid mussel thing is just fascinating to me. Okay, so this chunk is going to be fun. It's a little bit of, we've gone through some fun facts. We'll go through some fisheries. Now I'm going to do a very brief history of stock assessment efforts in the Great Lakes. We'll say a brief history according to Chris, starting with mainly catch-it age assessment modeling and moving forward from there. Please recognize, if you don't, that there is a rich history of assessments and fisheries science work that has happened in the Great Lakes before what I'm about to show you, right? Like the Great Lakes appear in Baranov's selected works on theory of fishing, and Beverton Holt and Larkin's epitaph on MSY. There's a ton of literature and a lot of really great fisheries scientists have worked at Palahaimo. A lot of folks have worked on Great Lakes fisheries. Okay. So stock assessments in the Great Lakes, in terms of age structured assessments, probably the first integrated age structure assessment models in the Great Lakes were for Lake Erie perkins, so walleye and yellow perch, probably in the 1980s. That's about when things started kicking off there. I know there was some early work with Cajun, and so that was with kind of an assist from Quinn and DeRiso. And this is Jim Bentz has communicated this stuff to me. Jim Bentz spent a lot of time working on Great Lakes fishery stock assessments. Prior to the Cajun stuff, there was some sort of VPA, virtual population analysis, used for the Lake Erie perkid fishery. And there's other examples of VPAs being fitted in the Great Lakes. So like Andre and Carl Walters fit a VPA for Green Bay yellow perch. I found a paper, 1994, Canadian Journal of Fisheries Aquatic Sciences, the other day. I was like, where did that come from? Point is, there's been a few models like that kicking around the basin, and there's certainly, folks are certainly familiar with age structured tools in the Great Lakes. Jim Bentz recently retired at the QFC. He's a co-founder of the QFC. That's the next point. He and Mike Jones co-founded the QFC in the early 2000s, but Jim Bentz started here in the early 90s, and he really is the one who initiated what we think of when we think of integrated age structure assessment models for like lake trout and Lake Superior. So he did a ton of work and kind of laid the groundwork for a lot. He brought RTMB to the Great Lakes, frankly. He's using it from the early days, right? And Jim just retired back in June, so he's been around, and he's a hoot to chat with. If I had to like take a bird's eye view and kind of like explain how Great Lakes models are fitted, at least the ones that are used for management around the Great Lakes, most of the models that I've seen, if not all of them, are fitted using, let's say they're just pretty old school assessment models, right? So they're fitted using penalized likelihoods, iterative data weighting schemes. They're pretty much all fitted using RTMB. And I said old school, what do I mean? Well, for example, the other day, postdoc I'll introduce later in the talk, and I were trying to root through this selectivity function that we saw in a Great Lakes fisheries assessment model. We couldn't figure out where it came from, and we went back to Nick Fish's thesis, actually, and he actually had the citation for it. It went back to like Fourier and Archibald, 1982, right? So that's what I mean when I say old school. Like some of the things kicking around, some of these models have been around for quite some time. Not that there's anything wrong with that. That's just, we've had to do a bit of digging to figure out where some of these things come from. There've been a few other types of models fitted. So Emily Lidgestrand, some of you know, she just did a bit of work with state space models for Lake Whitefish. She published that, I think, in Fisheries Research. So there's been research on some state space models, but I'd say that's been pretty limited. And those models haven't been used for management, that's for sure. So that's sort of the state of, or stock assessment models as I've seen them in the last year and a half that I've been here in the Great Lakes. I italicized some on this slide to convey that this is one small chunk of the assessed stocks in the Great Lakes. But in no particular order, there's a number of salmonid fisheries for introduced species like Chinook salmon, which were introduced to prey on alewife and develop a recreational fishery. I haven't worked on these at all, but these are important assessments that the state agencies and folks will run. Steelhead, salmonid and trout community assessments. There's some prey fish assessments, so alewife, smelt. Most of those salmonid and prey fish models are sort of aimed at understanding and managing predator-prey dynamics. Okay, so predator-prey communities via stocking and harvest, right? So they actually stock a lot of fish in the Great Lakes, and they use these models to try and guide how many fish they should stock, what size they should stock them at, all of that kind of stuff. I haven't really worked on most of that stuff yet. I've worked on a few of the alewife prey fish assessment models, but that's just starting. But most of the work that I've been doing in the Great Lakes has been with these bottom 2 points, or that's what it's like looking into the abyss. I have so much work to do on these bottom 2 points. So I spent a lot of time working on the 1836, 1842 treaty fisheries. Those are fisheries I'm going to talk about in detail in the second part of this talk, but they're fisheries primarily for lake whitefish, lake trout, and Cisco stocks. And again, I'll talk about that a ton in a bit. And then this Lake Erie walleye and yellow perch stuff, which is the single most valuable, I think, fishery in the Great Lakes. It's the only Marine Stewardship Council certified fishery in the Great Lakes as well. So these are just some of the places that the assessment models are being used in the Great Lakes. And so if I had to it's easy to swoop in somewhere, you learned everything elsewhere and just be like, oh, there's all these problems. But, if I had to gauge the state of stock assessment models in the Great Lakes, this is my 1.5 year opinion, and it's nothing more than my opinion on it. So a major constraint that most of these agencies and groups that run these models have is capacity limitation, right? I said this earlier, but many of the folks tasked with assessing the stocks have many other responsibilities that they have to do. And that's an interesting challenge to deal with. I've seen it so far where a lot of folks will know how to run a model. So they'll be given a model, or they'll inherit it from somebody who worked there before them, but they won't know how to change anything. And, there are notable exceptions to this. There are several great stock assessment modelers around the Great Lakes, but by and large, a lot of the folks have a difficult time knowing what to change, what that implies in terms of, where they should go elsewhere in the model to make sure they haven't screwed something up or things like that. So it's an interesting place. Oh, and I forgot to say this on an earlier slide. We don't really have formal stock assessment review processes like you do with NOAA, right? So keep that in mind. This next point, a lot of the assessment code has been taken from a few models and adapted to many models. If you want an interesting and slightly humorous read, go read about cargo cult programming on Wikipedia. But the idea here is, you get a model and then people keep adding to it, but don't really know what they're adding. And so you get these behemoths at the end of the day that make you want to weep. And that's led, at least in some cases, to code that's been pretty quirky. And it's made it difficult to compare among management units, even for the same species. There's certainly databases for, data, but there's usually a person who has to literally say, here's the data sheet to run this assessment model. So there's this step in between. I think part of that's due, each of the tribes have their own databases, each state has their own database, right? So there's this whole challenge of who owns the data and things that's layered in here. And when I started here, people told me, good luck getting anybody to use GitHub. Literally, that's what I was told. So, that's what it looks like from where I'm standing. I'm not the only person who's recognized this. And, for example, there was a code standardization effort initiated for some of the treaty water fisheries. And this predates me in the Great Lakes, but this effort was initiated in response to many things. So recognition that we should improve assessment model code, news about RTMB no longer undergoing active development. I think part of the reason that folks were doing this particular code standardization effort with the treaty waters was the recognition that they might be able to fit more complicated or flexible hierarchical models using template model builder. And these efforts were really started for lake trout and lake whitefish. And so, 5 or 6 months into my job, when I started here, I saw Jim in Rome and then came here and slept for 3 weeks. And then, in March 2023, following CAPM, Jim Benson and I were trying to, build header files and stuff to try and standardize some of these stock assessment models, at least for the treaty water fishery. So that was March 2023. Fast forward to June 2023, I was hanging out with Sean Anderson up in Nanaimo for a Pacific herring stock assessment review that I did with Fisheries and Oceans Canada. And he basically was like, why are you doing that? Why don't you just do it with RTMB? And that's what the rest of this talk is going to be about, are those efforts for RTMB stuff.
And Chris?
Yeah.
This is Jim. I was wondering, do you have a slide on like data, like what are the monitoring programs? Or I'm just curious in this background to know what data you guys have to work with.
Yep.
Some of those.
So that's a great question. I don't have a slide on it because I can't share all the data, especially from the treaty waters, because I don't own it. It's really dependent on the fishery because all these different agencies monitor things in different ways, right? And so like, maybe let me talk about the treaty water stuff, Jim, which will talk about part of the problem with at least the whitefish assessment models. But it's in the case of the treaty water stuff, each of these tribes is an independent sovereign nation, right? And so I'm not answering your question very well because it's not an easy question to answer.
Makes sense, totally, that's fine. Let's keep going, and I'll bring it up later.
So that's just like a highlights reel of the Great Lakes and some, different things that are going on in the basin that I've sort of been exposed to since I moved here. The second chunk is sort of the bit about, how we've been translating statistical catch at age models from ADMB to RTMB to standardize code and modernize code for like whitefish stock assessments in the treaty waters. I'm going to assume that most people don't know what that means, and I'll give a little bit of background on the treaty water stuff now. This work is, I was chatting with Kristen at the beginning, but a lot of you folks know Lisa. Lisa started here in August, and so a lot of the work that I'm sharing here is stuff that Lisa's led and developed, and has just, it's been fun to work with her. So she and I have done a lot of this work. She led it. I was teaching a class last fall. Lisa really laid a lot of the groundwork. I finished teaching the Bayesian statistics class and then immediately got to work helping her with some of this stuff. And so that's sort of the stuff that I'm going to present to you now. So the 1836, 1842 treaty waters in Michigan. So there was a series of treaties in the 1800s that guaranteed the right to fish and hunt to indigenous persons or like a few tribes in Michigan, okay? And so the tribes ceded land, often under duress, in exchange for the right to fish and hunt, okay? So this is the 1836 Treaty of Washington. I can't remember what the 42 treaty was called, but these are treaties signed with indigenous persons that guaranteed the right to fish and hunt, okay? And the phrase that you'll hear in the Great Lakes, and you've probably heard it in your part of the world as well, is, fishing since time immemorial, right? Like this is a big deal to indigenous folks in the Great Lakes. I love this picture. So this is from the early 1900s, and it's actually from St. Mary's River, which connects Lake Superior and Lake Huron. And it used to be shallow, this chunk of the river. And so you used to be able to go out and dip net whitefish in canoes. And so this was a traditional fishing method that used to happen there. You can't do that anymore because the Soo locks, which were installed for navigation purposes, are now in this part of the world. But the point is, folks have been fishing for a long time in the Laurentian Great Lakes. And so when folks talk about the treaty waters in the Great Lakes, it's actually kind of difficult to get maps on it, oftentimes because the boundaries have been contested. I like this map just to give a rough outline from Travis Brennan, the director of the QFC, wrote this book chapter, which is probably the best chapter describing a lot of this stuff if you're interested. But so when I talk about the treaty waters, 1836, 1842, what I'm talking about are, this stretch of the Upper Peninsula, so east of the Keweenaw and over to Whitefish Bay and Lake Superior, northwestern Lake Huron, and then these chunks of Lake Michigan. Okay, so that's the 1836 treaty waters, which has been where the majority of our work's been happening. The 1842 treaty waters surround Keweenaw Peninsula. Jim, when are we going out to Isle Royal? And then all the western chunk of Lake Superior. Okay, so this is what the treaty waters of the Great Lakes are. And there's a collection of different management units within these treaty waters. There's like, for whitefish, there's like 13, maybe 15, possibly more different management units that require stock assessments. And so we want to talk about this stuff, we got to kind of talk about some of the legal history of the treaty waters. And so, you know, it turns out indigenous folks pretty much only get rights in the US if they litigate, right? So there's this court case, US versus the state of Michigan, and it's called the Fox opinion. So what happened, I think 6 years prior, is Al LeBlanc from Whitefish, he's from the, he is from the Bay Mills Indian community, or was. He went fishing out here with a gill net, and he got arrested and charged, right? And so several years later, the U.S. took up an antitrust lawsuit or suit against Michigan. The Fox opinion was established, and that guaranteed the right to fish and hunt, and like upheld that right. And so then there was this whole series of things called consent decrees, which are legal agreements where neither side admits fault. And these have outlined how fishing will happen in the treaty water. So they're supposed to be every 15 years. The 2023 one was a little bit later because of COVID and some other things that I'll talk about in a bit. So these consent decrees basically are like legal, you know, they're law that outlines how these fisheries will be managed, etc. So for the 1836 waters, at least there's 5 groups: Sault Ste. Marie Tribe of Chippewa, Bay Mills, Grand Traverse Bay of Ottawa and Chippewa Indians, Little Traverse Bay bands of Ottawa Indians. If you don't get the bands right, you'll get corrected in the Great Lakes, and Little River Band of Ottawa Indians, okay? So those are the 5 groups in the 36 waters, at least. I think there's others in the 42 waters. I'm not sure offhand, honestly, because most of the work I've been working on has been in the 36 waters. But these decrees kind of outline a management procedure, okay? you folks are used to thinking about management procedures. The law, the letter of the law says, like, thou shalt monitor this way, they will assess this way, they will run assessments, they will estimate mortality, and then they will allow this much mortality on top. You know, this is the total mortality cap, and it's literally all established through extensive litigation, okay? And it's mainly for lake trout, lake whitefish, and cisco. There's this, the framework within which this works is sort of like as follows. The consent decree establishes this thing called a technical fisheries committee, and that's got representatives from each of the groups up here. And that's like where the politics of quota setting happens. And then there's the TFC, the Technical Fisheries Committee, set up this other thing called the modeling subcommittee. And that's the group that Lisa and I have primarily been working with, and that the QFC has worked with historically. This is an aggregation of biologists from the tribes, state, federal agencies that, you know, sometimes they collect the data, they amalgamate all the data, get it into the framework to put it into the RTMB models to run it. They then set a quota and they pass it on up the chain to the TFC, okay? So this is real weird, right? Like, this is a lot of stuff going on, but this is what we talk, when we talk about treaty waters in the Great Lakes, this is what we're talking about. And so this most recent consent decree in 2023 established that fisheries are going to be assessed every 3 years, and whitefish are due December 2024, which is why every other word out of my mouth in this talk is lake whitefish. There's an asterisk by the 2023 consent decree because the Sioux tribe has not signed on. So at this point, it's a non-consent decree. And let's just say these fisheries have been and remain a contentious issue. So this happened when was it? I thought it was May. Yeah, May 18th. So the judge okayed the 2023 decree. Shortly after Lisa got here, she gets here 1 month later, this happens. The Sioux tribe, so the most powerful indigenous group east of the Mississippi River in the United States, right? They're a big deal. They appealed the ruling to limit tribal fishing rights. And more recently, this just happened last month. The Sioux tribes challenged the Michigan, they call it the Michigan fishing deal in this headline, child's preposterous rules. And so that's the context, socio-political context within which these assessments are happening and this framework occurs in, and everything, right? So it's a pretty complicated system. It's pretty wild. It's been a wild ride. I know sometimes when I give the first part of this talk, and people who aren't in the Great Lakes get blown away by the $7 billion number for Great Lakes fisheries in terms of value. And a lot of that's recreational. So sure, some people are like, it's not that much. But I think the thing to think about in the context of Great Lakes fisheries is the importance of these fisheries from an indigenous perspective, particularly in the context of upholding indigenous sovereignty in the case of the treaty waters fisheries, or the fact that at least in Anishinaabe culture, this blows my mind, whitefish make an appearance in their origin story. So like, to say that these things are important is kind of an understatement, right? And so to be working on this stuff's been pretty wild. So I said we were modernizing the assessment models and translating models from ATMB, statistical catch age models from ATMB to RTMB. And this is UW, so people will know what this stuff means. But the RTMB developed by Casper, it's an ATMB inspired R package. It combines a bunch of important and fancy external libraries. It's been in continuous development since 2009, or TMB has, I guess. And it can implement Laplace approximation if you want it. But the big benefit of RTMB, at least in my world, is that I can just write code completely in R, right? And so that is the difference, right? You get all the speed up and everything of automatic differentiation, C++, but you can basically code it directly in base R, and that's been pretty cool. Again, I'm not going to show you a ton of just programs we've written because that's kind of silly, but the main point here is that RTMB programs are simple, right? So you install the package, create a data list, a tagged list, put some data in it, create a tagged parameter list. It's got your parameters in it. Write a function that returns the negative log likelihood. Make a defun. Run NLMIMB to minimize it. Pass it the gradients, and then you're basically done. And I think the thing to think about here is, yeah, this is a stupid example. It's very simple and not a stock assessment model. But what we've found is that the RTMB architecture and framework extends to much more complicated non-standard models quite easily. And so, why did we actually think about making the jump to RTMB? Simplicity, right? Pragmatism over dogmatism. What do I mean by that? Well, a lot of the folks that we work with are biologists by training. They're not programmers or statisticians, right? And so they might be able to speak R, but they certainly don't know C++ or ADMB. And so from a teaching perspective, that lessens one barrier that I have to teach folks if I want to teach them stock assessment or teach them how to think about models and be critical of models and the inferences coming out of those models, particularly when they're in important management contexts like the treaty waters, right? And so those are really our main reasons for doing this. And I guess, again, the big thing here for the QFC is just, it's part of our strategic vision, our emphasis on teaching folks and building capacity within agencies around the Great Lakes. That's been huge. And it's a huge reason that we've switched to RTMB. It feels really weird giving this talk with Jim in the room, but we got a lot of experience translating many small programs, spatial temporal models, SPDE models, whatever. They all work fine, or at least they all have for us. Maybe not Jim's models, but they work fine for the stuff that I've been showing people. And I think the thing that's not really the point of this talk. The main point of this talk is that we've been translating these statistical catch age models that folks had kicking around the basin for a long time to RTMB. So far we've converted about 12 statistical catch age models from ADMB to RTMB. And those were about 1,500 to 2,000 lines of ADMB code. None of these are state space models, right? These are just penalized likelihood, standard stock assessment models. I got bigger problems on my hands than dealing with state space models right now. But in all cases, we've been able to get the RTMB models matching the ADMB objective function out to machine precision. And I think the key thing is that in all cases, it's resulted in far simpler code. Okay, so we've been able to do the same thing, much less code, right? That's been our experience. I said I wasn't going to throw a ton of code at you, but basically when I say far less code, what I mean is in about 100 lines of RTMB code, we can really assess probably 13 of the 15 whitefish fisheries in the Great Lakes. And that's been pretty wild, right? So if you want to play with this, you can click on this link. Leachy and Kristen said they were going to send the talk out to the listserv. So this will take you to a link with a simulated data set and this whole thing. But it's basically like 80 lines of base R code that was doing what thousands of lines of ADMB code were doing before, right? And part of that's that we're trying to code it in a different way, and we're just going through it. And we've got the benefit of hindsight, right? Like we can kind of look at all the models and make some choices. But the point is, it's simplifying our workflow quite remarkably, and I think that is powerful. Much lower development time, at least for us, relative to ADMB or TMB. It works with the debugging tools in R like browser, and so that's just been huge. You can walk through the models really quickly and figure out what's going on. No need to compile or recompile. Able to put all the code in a single environment. The code is simple, right? I think that's been huge for us. And it's I mean, this is early days, and none of this is that novel, right? We're just converting models to RTMB. But I think it really down the road is going to open the door for more interesting analyses or research in this in the Great Lakes, right? Especially because we're able to get folks who might lack programming expertise in like C++. We might be able to get their eyes and their creativity and their insights on some of these longstanding problems in the Great Lakes. So that's exciting and fun. This slide's kind of a joke, but the biggest technical challenges we've encountered with RTMB, we've had a few nonsensical error messages, but you can always use browser to walk through the stock assessment models. Oh, somebody talking?
We're just laughing.
Just laughing.
Oh yeah, grumpy graduate students who just learned TMB. So I had a buddy, dear friend. I taught him TMB for all these hierarchical models. He's trying to fit. I came home from Nanaimo, and I was like, I can do everything I showed you in 700 lines of TMB code and like 30 lines of RTMB code. And he's like, I hate you. Jim, and he held out for like a week, and then he's like, no, I got to do RTMB. Okay, so Jim Bentz had a meltdown with RTMB unstructured. I love Jim Bentz, and I have many meltdowns that he's had to deal with, far more than Jim has had, but he got to do a good fight with RTMB unstructured. But that was just because he couldn't read the hell file that I give him crap for. And then, standard shit, matrix RTMB package inconsistencies. And for a while, if anybody was using it, there was this 80 overload trick with the assignment operator that we had to do. But I think I was checking this week with Lisa. I think this has been fixed, and so we don't really need that anymore. Something that I wasn't like when we started this RTMB quest, we were like, we're going to simplify the code base. It's going to be more transparent, all this stuff. Cool. We'll be able to better incorporate hierarchical modeling if we want to, whatever. But something that's really popped out at me in the last 3 months in particular is just the ease of diagnostics once we've gotten our models into this framework. And if you code in TMB, this is nothing new, but like if you're used to ADMB, this is fascinating to me. So like, say you want to make sure that your model's solving to a unique solution, right? So make AD fun, run the model, get the MLEs, write how many lines? 6-line function to jitter the MLEs by a CV of 10%, rerun that stupid thing 100 times or however many times, and plot it, right? So do like a jitter test to make sure you're always solving back to the same place. Lisa and I were actually teaching some folks earlier today. We were trying to do this with ADMB, and I know you can do it with like pin files and all kinds of other things, but this is just pretty elegant and straightforward, right? And it scales to models of arbitrary complexity, or at least it has for us so far, right? Profile likelihood, right? I got a bunch of biologists who don't speak ADMB and don't really want to learn, if I'm being honest. And I want, but I still need them to be able to think critically about the models and where the problems might lie. So, I want to profile an initial abundance parameter. Just do it like this, done. Profile any model parameter that you want in the whole thing, right? I know that this isn't novel for a lot of folks, right? But it's been very powerful in pointing out like, hey, this parameter is partially identifiable, or your prior's gluing this model together, holding this model in a particular place, right? That's been a powerful tool for us. One step ahead residuals, 1 line of code, great. There's a lot of technical voodoo going on there, but that's been nice. Thanks, Cole Monahan. If you want to, you can very easily map out the solution space, right? The likelihood surface if you want, or you could do a fully Bayesian analysis if you wanted to. And I think this slide is important for a couple of reasons. But one, if you don't like HMC, you can code whatever algorithm you want, right? You just hand code the thing. It's not that hard. And then the other thing that's fascinating about this, like sometimes people will be like, oh, I don't like the Laplace approximation for random effects. It doesn't work that well or something. And then you just MCMC it if you feel that way, right? So this has been really awesome. And then like, again, this one was the one that really blew my mind. And I guess I had 2 little mind-blowing emojis up here, which apparently didn't come through, but like, you can simulate a data set from your model with basically 1 line of extra code. So you don't even need simulate blocks like you used to in TMB, and you can create an entire simulated data set. So if you want to check things like whether your model's obeying consistency of the maximum likelihood estimator, right? It's like a line of code, or you could do whatever you want with this simulation. So those have been the things that have been really mind-bogglingly helpful in the context of capacity-limited fisheries assessment in the Great Lakes. So it's not all sunshine and butterflies. I think like from a scientific perspective, the simplicity is great, right? Like all this stuff is good. I think in the context of very contentious treaty waters fisheries, this gets a little more challenging. And, this is one of my favorite photos of the Great Lakes by David Sanford, the bane of the Great Lakes. The bane of RTMB is how simple it is. And that's led to some shall we say, just interesting issues. So the simplicity is a strength from a scientific perspective, right? And having simple RTMB models has meant that we're able to actually use the RTMB models and these diagnostics to identify issues in the ADMB models more easily. So if you want to think about it this way, injecting a little bit of RTMB code into the Great Lakes has given us fresh eyes, so to speak, with which we can look back on the ADMB models and be like, oh, maybe we shouldn't have done this that way or whatever, right? That's been really challenging in the context of contentious treaty waters, tribal fisheries assessment stuff, right? And I think that's been the thing that we've been dealing with, because we all know when you make a small change to an assessment model, that can change your perception of stock status, and that's important in this context. So the bottom line, I think, if you're trying to go through this sort of stuff and you're trying to do this stuff, it's not really a one-to-one translation, even though we can get the objective functions to match out. Using these tools has basically allowed us to take some deeper insights and, unveil some of these Great Lakes stock assessment models. If you don't believe me, these are some testimonials from some of the partners that we work with and the tribe. So the first one's from a biologist from the state. RTMB is easier to debug, requires fewer lines of code. More of our state biologists are able to better contribute to stock assessments because they can code, or at least read our code. These two really hit me in the feels, which is saying something, because I'm an assistant professor and I don't feel anything other than being tired all the time. So these two really hit me in the field. So this RTMB GitHub training is how you build trust with the tribes. This is in the middle of this contentious thing that's going on right now. So, that's fun. This one I love. Wow, you two, super cool stuff. This is Lisa and I got through the gamma selectivity model, no problem. When we get this worked out, it's going to revolutionize our process. And this is important. We'll allow so many more voices to be heard, as nearly everyone can talk R, but not C++. So something that I haven't said so far is that, the tribes, if they have an assessment biologist, that biologist is also tasked with collecting data or dealing with human rights issues or any other number of things that this tribe has to deal with, right? So their assessment biologists at best have a limited amount of time to run these models. And so the more transparent and clear we can code those stock assessment models, the better. And I think, at least from my perspective, this is increasing inclusivity and equitability of stock assessments, at least in these fisheries. And I think that's really cool. Word's starting to get out. Lisa and I are very busy. Agencies all over the Great Lakes are sort of pushing for this now that they've seen what's possible. And that's been our experience, at least. I only got like a few more slides, but what's the future of RTMB in the Great Lakes? Well, I think the first thing is we've got to deal with these whitefish assessments. We've got them due December of this year, and then next year we'll be doing lake trout assessments because they're on alternating cycles in the treaty waters. Something that's pretty cool that's popped up is that Lisa and I are leading stock assessment working groups with the collection of tribal assessment biologists, federal government scientists, Michigan Department of Natural Resources folks. We actually just led our first one 2 hours ago, so I'm even more tired than normal, but Lisa led it, but I'm still tired. So we're kind of doing these bi-weekly things, trying to train folks in some of these tools and methods that we've been talking about here today. Beyond the treaty waters fisheries, I think the next big thing that we're working on is walleye and yellow perch models in Lake Erie. So if you're not familiar with Lake Erie, it's one of the flagship fisheries of the Great Lakes. It's binationally managed. This is Marine Stewardship Council certified fishery in the Great Lakes. And these fisheries management programs and models, everything have gone through extensive stakeholder development, right? They're embedded in this huge structured decision-making process. And so this is going to be wild. This is the next trial by fire test that we have for RTMB. There's walleyes. This is walleye, this is yellow perch. These are what the two perked fisheries are. But basically, like these are the models that we're going to be trying to play with and try to modernize and adapt to this RTMB framework. These data sets are fundamentally different from the data that we're talking about with the whitefish models. They have a lot of different data, one of the biggest acoustic telemetry data sets in the world is actually in Lake Erie. That's the data set I was talking to you about, Jim. Anyway, that's all embedded in this system. So there's going to be some really wild stuff going on. And I think the other thing, I forgot to say this, but like politically, this is a very different system than the treaty waters fisheries, right? Like this is an entirely different system. I think that's going to be really exciting and fun. And there's a number of ways to talk about the importance of the Lake Erie perkit fisheries and where we're trying to go with that stuff. In particular, I could tell you that I measured it out. So there's like 38,000 kilometers of nets for the commercial portion of this fishery. It's commercial and recreational fishery for these things. 38,000 kilometers nets. If we ran that from where I'm at in Lansing to where you're at in Seattle, you could stretch those nets back and forth 10 times. That's how much fishing pressure there is for these perkit fisheries. So there's, it's going to be fun to play with. And it's a super intense recreational fishery as well. So that's just going to be wild. Yeah, I could tell you it's worth $1 billion a year, all that stuff. But this picture blows my mind. This is my favorite picture dealing with the importance of Lake Erie perkit fisheries. This is the walleye drop in Port Clinton, Ohio, which they do on New Year's. Yeah, that's all you need to know about the Midwest, summed up in one picture. Some places drop a ball. Port Clinton, Ohio drops a very large walleye. So that's where we're headed soon.
Is that a real walleye? Like a dead one, I mean? Not a plastic?
I couldn't hear you. What?
Is it a plastic walleye or a taxidermy? No,
Dude, I don't know. I'm going this year. If you show up, I'll take you. I'm making it a point to go here. Like as a fish scientist, I have to go here. Just to wrap this up, I think so outside of the treaty waters, this part of the world here, and these Lake Erie assessment models, what's the future of RTMB in the Great Lakes? Well, I think a big thing is just what that we're grappling with right now is thinking through a bunch of different ways that we might organize this code base to further the QFC's mission in the Great Lakes, to build capacity, train folks in these agencies, teach them about stock assessment, right? Like we don't want to be repeating ourselves all over the place. I don't know what that means, whether it ends up being a package or some fancy repository with different lessons and, transparent, simply is, code and models that are as clear as we can make them to try and teach folks. I don't know I don't know what that ends up being, but I think that's where we're trying to go with it, or at least that's where I'm trying to go with it. I don't know how. I'm actually kind of on time. This is remarkable for me, but if any of that stuff interests you, we've got 2 research assistant professor positions posted right now at the QFC. They start at $75,000 a year, which doesn't sound like a lot of money, but that's because you're used to Seattle. And if you come to Michigan, cost of living is a lot lower. It's about that much lower, right? So that's the salary for these 2 positions. They're probably great stepping stone positions, right? They're not meant to be like forever homes, but they're meant to inject new views into Great Lakes fisheries assessment to work on specifically the treaty waters stuff, training assessment biologists, and we got another position for that Lake Erie problem that I was talking about, particularly the yellow perch, but also the walleye. Michigan's a great place to live. I'm biased, but it's got the most public land east of the Mississippi River. A note on experience. Look, it's you're UW. If you've taken Andre's courses, I'd love to hear, and you have a PhD, I'd love to hear from you. I think we've got a lot of important and interesting stock assessment issues. And I think like if you're a quantitative scientist and you've got some skill set that you want to throw out into the world and try and make an impact, is a good place to lay your stock assessment skills to bear, I guess. So we're going to start reviewing positions on 15 May. I went over time. Okay. I'd like to thank a whole bunch of people, but Anders, Nielsen, Carl Walters, Charlie Belinsky here at the QFC has been really helpful. Lisa Chong. But yeah, somebody chat. There's a question in the chats, maybe. Anyway, thank you.
Well, that was a very compelling ad to go to Michigan. But thank you for a great talk. That was great. I know Kiva has just raised her hand. I can allow you to unmute yourself, but in the meantime, does anybody here in the room have any questions?
Can you
Kiva
hear me?
Yes.
Great. Thanks. That was a really fascinating talk. So I'm a stock assessment scientist at NOAA. And when I heard you say that we're using penalized likelihoods and iterative data weighting, and there's all this resistance to GitHub, those are all things we deal with at NOAA too. And that's how we do our stock assessments on the West Coast. But I think one difference that I notice is the human capacity is different. So we do have more human capacity. And so we've built this whole ecosystem of tools around these older methods. And so I think there's a lot of fear that advancing these methods that you're trying to advance means losing some of that human capacity. And so I guess I'm trying to phrase a question, but like, do you think more of the benefit, do you think the tools provide more of a benefit, or do you think the human capacity provides more of the benefit? And sort of how do you go about this sort of resistance to change when people really are experts in what they're doing right now?
There's a lot there. It's nice to chat with you, actually,
Yeah.
rather than just email you.
Yeah, totally.
So I don't know much about the capacity side of things. I've only worked in places where there aren't a ton of analysts, and usually I'm the person trying to do the models. That's just sort of been my history. So I can't speak too much to other places or things like that. What we've been doing is using the RTMB models and trying to be gentle. And sometimes I'm better at this than other times. And using the diagnostics to be like, hey, what if you poke your ADMB model in this way or in that way, right? And try to let folks realize some of these things that we're seeing. What was the other part of your question, Kiva?
I think sort of like balancing, like, do you think there are more of the problems are coming from using these older tools? Because we can do all of those diagnostics on our ATMB stock synthesis models. People spent years writing code to do it. So do you think more of the benefit has come from, using these more modern tools? Or do you think that more of the benefit has come from sort of the other aspects?
So I think you're absolutely right. You can do all these things in ADMB. It's not that you can't do them. It's that in the context of our fisheries, which don't go through formal reviews or things like that, at least what I've seen, and this is my hypothesis, the harder something is to do, the less likely somebody is to do it. So there's that part of it. I don't think it matters for your fisheries as much, but for these fisheries, I got to teach people, one, and then secondly, get them to easily be able to run some of these diagnostics. So the teaching, honestly, the teaching thing for me is the biggest bit. Like it's far easier for me to teach somebody 30 to 100 lines of code than it is for me to teach them some complicated coding structure. But that's been my experience, and that might, others might have different opinions. I'm not sure.
Yeah.
I feel like I did a terrible job of answering your question.
No, I think this is probably a better conversation for a beer. That was great. Thanks.
I will note that it's 1:31, so if folks need to hop off, feel free to. And Chris, if you're willing to stay on, I think Jim Iannelli has both a controversial question on the Q&A or controversial comment. I don't know, whatever, some comment. And also Jim Thorson in the room has a question as well. And also Jim Iannelli has his hand raised.
No pressure, just the Jims.
The room can go ahead first.
Yeah, thanks, Chris. And it's awesome to see this. And hey, yeah, so I was curious, like, my big concern with RTMB has been about like the drawn from the global environment. And like I kind of like TMB for being really closed off to like, naming conflicts and drawn from like global environment accidentally. And I guess I was just curious if you get like doing it with new users, like have you had like all those kind of like type errors or like all these sort of like boneheaded kind of accidents where you wouldn't necessarily...
that's a fair critique, right? Like strong typing or things like that. But I guess like of the problems that I've seen in Great Lakes assessment models, those are not our problems. Like I'm just trying to get people to get models that converge at this point, right? Like, so I hear what you're saying, but I'm also not, I guess it hasn't been as big of an issue with what we've been working on so far. Will it be an issue in the future? Maybe, I don't know. It'd be a good conversation for a beer with Anders as well. I'd love to chat with you and Anders about that, but yeah.
That's fair, that's great. It sounds like you've taken it further than most people I know, and so that's awesome that it hasn't popped up.
I didn't really have an option. I had 2 people and a Great Lakes worth of assessment models to work on. So that's why we went that way, frankly.
Okay, Jim Iannelli, you're allowed to talk.
Hey, Chris, great talk. I really enjoyed it. And similar question to the ones before and relative to scoping. So AD Model Builder was developed for people like me who couldn't program in C++.
Yeah.
And it was basically almost the same arguments, obviously sharper tools for RTMB now. And I think it's awesome. I guess my question is, so here's the evolution of ADMB as I see. People stopped learning how to use it educationally and instead learned a package that was written in it. My question is, how long will it be before someone writes a giant RTMB package that nobody's ever going to want to look at? Sorry about the
Probably next week. I don't know. Like I know Anders has already coded up most of SAM in RTMB, right? He's got a model called Baby SAM. It's like 100 lines. It's like 100 lines of code. He can fit like 80 to 90% of the IC's assessment models, he told me. So I don't know. I guess I'm trying to like disentangle the developing a package bit from teaching. And I spend more time teaching than I do developing packages. But I agree with you that, you know, ADMB is that tool. Good ADMB code is a thing of beauty, right? It's elegant, it works, it's fine. It does the job, and good coders in ADMB are great. I think in my context, the thing that I keep coming back to is the fact that there's probably 5 people in the Great Lakes Basin that are comfortable with ADMB code, right? And so that's just been a huge challenge. It's always been a challenge in the Great Lakes, I think, but maybe I'm misinterpreting your question. I'm also tired. It's the end of the day for me. I don't know. Is this helping at all, Jim, or am I just?
No, it's just an interesting problem. You know, it's like ADMB was a great teaching tool about stock assessment, you know, the simplest a few lines of code. And this is obviously a great teaching tool and something that's super powerful, you know, more powerful and better. But are we going to end up in the same place, I guess, where, oh, I know how to use R, I know how to use the command line or whatever it is, therefore I can use, you know, the next.
I mean, model. Yeah, so I think that's, and I think that's it's an important question that I think we're going to have to ask ourselves as fisheries scientists in general. But I think in the context in the Great Lakes, and I'm trying to apply these models, because they're so contentious, they're like literally in courts right now, right? Like people don't send emails, they call me because the things are in courts. I'm trying to code the most transparent, like just ruthlessly simple does not mean easy, but transparent stock assessment models. Maybe that is a one-off thing for this particular fishery, and maybe it's not a package that I can use to assess every fishery everywhere, but that's sort of why I'm doing it that way, for better or worse. That might bite me in the ass later on, but
I guess the benefit would be that, you know, you're teaching people about the actual nuts and bolts, and then when the big one comes, they'll feel more comfortable knowing how to look through the code.
That would have been a better answer. Hey, you'll appreciate this story. I was chatting with Anders in Halifax. He told me that you're the best ADMB coder that he's ever worked with.
I'm blushing.
Yeah, I know. So I figured I'd share that. Anyway, I don't know. Are there other questions, Leachy, or am I free to go?
I think you deserve multiple years.
I'm gonna have multiple beers. I just want. Are there any other questions? I can't see.
No, I think we're good in the room, and it doesn't seem like we have any more online. So thank you again. This was amazing. This was a really great talk, and I hope you have a great rest of your day.
Thank you so much. If any of you are ever in Michigan, let me know. We'll make something happen.
Paul Christensen says we have to ask you more questions so you can't sleep.
Joke's on them. I already don't sleep. Anyway, I'll talk to you folks later.
Thanks, Chris.
Thank you. Thanks, everyone.
Awesome. I'll stop.